going to learn the substitution method for solving systems of linear equations. And the substitution method takes advantage of the fact that when a system of linear equations has a solution, the x and y of both equations are equal because they intersect at a single point. And at that point, the x of this equation is equal to the x of this equation. The y of this equation is equal to the y of this equation. So what I can do is solve for one of the variables in the equation. Write this equation in terms of just x or in terms of just y, and then make a substitution. And then solve for one variable, and then take that variable and put it back into the equation, and then I get the number for the x or the y, whichever I was solving for. So for now, I'm going to pick the second equation because it's easier for me to reorganize it into something in terms of one variable. So I'm going to pick the second equation and I'm going to solve it for one variable. Now that I have this equation written in terms of x, I'm going to substitute this into the first equation. So what I've done is taken this and substituted it in for y. Now I have an equation written in terms of just x, and now it is a very, very simple algebra problem because there's only one variable. So now I have the x-coordinate of the solution of this system of linear equations. Now what I do is I take this x and put it into either the first one or the second one. It does not matter because where they intersect is at one point. Both of these lines have the same point as the solution. So it does not matter which I put it back into. I'll just pick the first one again because they're smaller numbers. I don't have to multiply it. So I'm going to put in y is equal to, minus 2 times minus 6 is equal to 9. I subtract. So now I have the x and y coordinate, so I have the solution. So the solution to this system of linear equations is minus 6 minus 3. And this is how to go about solving for a system of linear equations using substitution. Now there are a couple of other things that can happen. This was a situation where there was one solution, but as I mentioned previously, there are three things that can happen with lines. Either there's an intersection, which was just illustrated with this example. Second, there can be parallel lines where there is no solution and the lines are inconsistent. And thirdly, we can have two of the same line, two lines on top of each other, where we have a consistent, dependent system of linear equations. Let me do some more examples where one of those things might occur. Here I have another system of linear equations, and I want to find the solution. I'm going to use the substitution method again. I'll use the first equation this time because it's easier to change it into one variable. I'll say that x is equal to minus y plus 3. And it doesn't matter if it's x or y. We'll just solve for a different variable. So I've rearranged this first equation. Now I take this and I substitute it into the second equation. And here, the variables are going to cancel each other out. And what I will be left with is 6 is equal to 9, which is an untrue statement. And if I get an untrue statement, then the lines are parallel. The only time that the variables are going to cancel out is when there's a parallel line, or if there are two of the same line. And in fact, what I should do is, to prove that these are parallel lines, I'm going to change them into the standard form that I'm used to seeing them in, y is equal to mx plus b, where m is the slope. Parallel lines have the same slope. I'll take this first equation and I'll write it in terms of x. Y so x plus y is equal to 3. Y is equal to minus x plus 3. So m is equal to minus 1. I'll take the second equation, rearrange this, and divide by 2. M is equal to minus 1. So here I can see that M1 is equal to M2, so the lines are parallel. And that's an easy way to tell if there's going to be parallel lines or two of the same lines. If the line was the same, then these would be the same. But since they're not, then they're parallel lines. Because two of the same line would have the same slope as well. But also that the y-intercept would be the same. B, remember, is the y-intercept. So that's a very quick way of checking to see if there are going to be parallel lines or two of the same line, is to check and see if the slopes are the same. Which is going to make kind of this next example pointless, but oh well, we'll do it anyways. So I'm going to use the substitution method for this one. I'll use the second equation, rearrange it in terms of y. Substitute this into the first one. Distribute. I didn't mean to rewrite it again. And again, these y's are going to cancel each other out. And I'm left with 12 is equal to 12, which is a true statement. So if I get a true statement, that means the lines are the same line. They're consistent, and it's an independent system, or a dependent system. And if I rearranged these two equations, I can get the same line. If I divide everything over here by 2, I'm going to get x plus 2y is equal to 6. And this second equation, if I multiply everything by minus 1, I get x plus 2y is equal to 6. And I can see that they're the same equation. But when using the elimination method, if the variables do not cancel out and there is a definitive answer, then they are consistent and independent, and it's just two lines intersecting. If the variables cancel out and I'm left with an untrue statement, then they are parallel lines. If the variables cancel out and I'm left with the true statement, then they are the same line.